Lesson 95 is called Concepts of Integers. If you understand whole numbers, it's pretty simple to get the concept of integers. Whole numbers, if we put them on a number line, we could draw a number line and put 0. 0 is the smallest whole number. Next is 1, then 2. Now the whole numbers they're at these exact points, 0, 1, and 2. They're not the things in between 1 and 2. And integers are defined as the whole numbers and their opposites. So imagine this just keeps going, 1, 2, 3, 4. Then we could also say the opposite of positive 1 is negative 1. Opposite of positive 2 is negative 2. And we can keep going to the left on the number line. So this is a representation of all the integers. This is one way to represent them with the number line. Another way to represent it is to list them. But we can't list all of them because it goes on and on forever. So we go dot, dot, dot. And we go in the other direction, negative 1, negative 2, dot, 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 and put parentheses. And so this shows us, using examples here, that these are the integers, and then with a number line. And the arrowheads are important because it means it continues to the right and to the left. Lesson 96 is entitled Compare and Order Integers, and for 6th graders this year, this was the lesson I wasn't here for, so you actually have a whole YouTube video that you could look at on Lesson 96. So I'll make it kind of short. The idea here is that you can put integers in order from least to greatest or greatest to least, and pay attention to the directions if you're given a problem. Typically you'd be given a set of numbers all out of order, like negative 3, 0, 5, negative 4, and maybe 2, just as an example. And you have to put them, let's say, least to greatest. Well, in a number line, the smallest numbers are to the left. So negative 4 of this set of numbers, negative 4 is the smallest because it's further to the left than anything else. So we can start with negative 4. And you kind of guess along with me, try to think ahead, what would be the next largest number? It's the only other negative number in the list, negative 3. Then the only number that's neither positive nor negative, 0. Now you're back in familiar territory. You have to consider the 2 and the 5. 2 is less than 5, and 5 is more than 2. And here's our list of numbers from least to greatest. Lesson 97 is kind of exciting because it's something that you hadn't done before, learning how to add integers, which involves adding positives and negatives. And we use a simple method of using counters to help you out. So if you have the problem negative 4 plus negative 2, you draw 4 negative counters, 1, 2, 3, 4, and then 2 more negative counters, and you just add up how many you have altogether, which would be 6. But you have to say that it is negative 6. Then when you go to negative 4 plus 2, you do get 4 negatives, and then 2 positives, which are represented with plus signs. Then you have a 0 pair here and here. That means these are 2 zeros. And what's left is 2 negatives. So the answer to negative 4 plus 2 is negative 2. And so that's a demonstration of how to use counters to do addition of integers. In lesson 98, we had more addition, and then it focused on how to use a number line to do addition. So we're going to look at these 3 problems we have here. The strategy is the same. Start at the first add-in, so start at negative 6. So we would start here. Then we would count over this many spaces, and if it's a positive number we're adding, we move to the right, or in this case, we're adding a negative, we move to the left. So we start at negative 6 and move 1 space to the right. Start at negative 6, go over 1, and where we end up at is the answer, which would be negative 5. So we know this would be negative 5. When we do this problem of plus negative 2, we would start at negative 1, and move 2 places to the left. So we start at negative 1. I might have pointed here inadvertently, but we should start at negative 1 and go 2 to the left, and we end up at the answer, which is negative 3. So this would be equal to negative 3. If we did it with counters, it'd be 1 negative and then 2 more negatives, same negative 3. Then looking at 4 plus negative 6, it would be start at positive 4 and go over 6 to the left. 1, 2, 3, 4, 5, 6, arrive at the answer, negative 2. Of course, the problem with counters and number lines is you can't do it with numbers that are very far from 0. Because imagine starting at positive 156 and moving 2,312 spaces to the left to add negative 2,312. It just wouldn't be very convenient. Neither would it be convenient to draw counters with something like that. So and most of you realized there is a much easier way, sort of intuitive, and I'll just talk about that briefly. If you have 60 negatives added to 30 positives, again, you wouldn't really want to draw 60 negative signs and then 60 positive signs. So you simply say, I've got more negatives than I do positives. There's 60 negatives and 30 positives, and the difference between the two numbers, 60 and 30, is 30, and there would be more negative counters here, so the answer would be negative 30. If the signs are the same, like I'm doing negative 8 plus negative 4, this would be 8 negative signs and 4 more negative signs for a total of 12 negative signs. So you just use logical reasoning to help you figure it out. If you understand how counters work, you can use logical thinking to help you know what the rules are for adding integers. We learned in lesson 99 that when we do subtraction of integers, we're going to follow a simple rule to change it to an addition problem and then follow the rules for addition. And that simple rule is keep, change, change. Keep negative 6, change subtraction to addition, and change negative 3 to its opposite, which would be positive 3. And then we say we've got 6 negatives and 3 positives. There's more negatives. How many more negatives? Whatever 6 minus 3 is, which would be 3. So the answer to negative 6 plus 3 is negative 3, and the answer to negative 6 minus negative 3 is also negative 3, because these two are they're the same problem. If we have 3 minus 6, we're going to do keep, change, change. So it would look, and you can actually just write the problem. 3 minus 6, and think keep the 3, change subtraction to addition of the opposite. So now we have 6 negatives and 3 positives. And it's a very similar, actually it's the same answer, oddly enough, negative 3. So just use keep, change, that's P, change, change. Same as we used it for division of fractions. It's the same idea. Works really cool. The final 2 slides are on multiplication and division. Just remember, it's not the same rules as addition and subtraction, but multiplication and division have the same rules as each other. This is not the same as addition, which can easily demonstrate with thinking about 5 times negative 4, which is the same as negative 4 added 5 times. Negative 4 plus negative 4 plus negative 4 another time. That's 3 negative 4s, 4 negative 4s, and 5 negative 4s. So when we think through this, negative 4 and negative 4 makes negative 8. 4 more negatives, negative 12. Negative 12 and 4 more makes negative 16. And 4 more negatives added to the negative 16 that we already have makes negative 20. So this would equal negative 20. Now there's a connection between 5 times 4 being 20 and 5 times negative 4 being negative 20. And that is, if the signs are different, then the answer is negative. Different signs. Now to keep in mind again, I'm cautioning you, this is just for multiplication. Negative answer, negative product. Same signs, both positive or both negative. Positive product. How's that different than addition? If you add 2 negative numbers, you get a negative number in addition. But for multiplication, if you do negative 5 times negative 4, you get a positive 20. If it's negative 5 plus negative 4, think about counters. You'd have 5 negative counters and 4 more negative counters. That makes 9 counters altogether, and they're all negative. The rules for division are the same as multiplication, which is kind of nice. If the signs of the 2 numbers you're dividing are the same, either both positive or both negative, the answer is positive. So when you do positive 18 divided by positive 6, positive 18 divided by positive 6, you get a positive answer, which is 3. When you do positive 18 divided by negative 6, you have a positive divided by negative, different signs. The answer is negative 3. A negative divided by a positive, same as this situation. The answer will be negative 3. when the signs are the same, in this case they're both negative, as these were both positives, it's the same effect. If both the divisor and the dividend, this is a dividend, and the divisor are negative, then they have the same sign, the answer is positive. So go back to the rules for subtraction. If the two numbers you're multiplying have the same sign, either both positive or both negative, the answer is positive. If they have a different sign, the answer is negative. You can only divide two numbers at a time. So you can say both numbers, but you can multiply more than one number at a time. So when you're multiplying two numbers, if they're both positive, the answer is positive. If they're both negative, the answer is negative. We generalize the rule, if you think back to multiplication, that if there's an odd number of negative factors, the answer is negative. If there's an even number of negative factors, the answer is positive. So you can kind of extend that rule. And that's it for the review for Chapter 8.